Okay, grade 8, this is a summary of the things you have to be able to do to be successful at your Chapter 3 Pythagorean Theorem test. So Chelsea and Ava asked me to put this on the video for you so you can kind of understand what are the things I need to be able to do. And it's the first one says, determine if a number is a perfect square using prime factorization, approximate the value of a non-perfect square using a number line, know your vocabulary, determine the length of a missing side of a right triangle by using either a drawing or a formula, and finally use Pythagorean theorem to solve contextual questions, aka story problems. So the first one we're going to look at is determining if a number is a perfect square using prime factorization. So I think most people know that 100 is a perfect square. But if I was to give the number 200 and say, is it a perfect square, it might be a little harder to determine if you don't know all of your perfect squares. So if we broke down, we can break down any number into the product of what's called prime numbers. So 2 being a prime number because the only factors it have are 1 in itself. 2 times 50 is one way to say the number 100. 2 multiplied by 50. So we can make this little tree-like diagram or a factorization tree. But since 50 is not a prime number, it can be broken down into the product of a prime number and another number, in this case 25. So 2 times 50 is one way to say 100, or 2 times 25 is another way to say 100. And if I break down 25, I can make it into the prime number 5, multiplied by the prime number 5. And therefore, 2 times 2 times 5 is one way to say the number 100. And when we look at those prime factors, if I can rewrite them, so instead of saying 2 times 2 times 5 times 5, we can say 2 times 5 times 2 times 5. If I can rewrite them like that and simplify two sides, I know that 100 can actually be represented by the number 10 times 10, which means that using prime factorization, I'm able to determine that 100 is a perfect square because the square root of 100 is 10, or 10 times 10 is 100. But with 200, if I was to break that one down, I could break it down into 2, which is a prime factor, times 100. I could break it into 2 times 50, just like I did before. 5 times 10 if I wanted to this time, different way than I did before. And 2 times 5. So 2 times 2 times 5 times 2 times 5 is one way to represent 200. But the problem is I can't rewrite them. I could put a 2 times 5 over here and a 2 times 5 over here. But that extra 2 I can't assign to one side and make them equal numbers. So therefore we can say no, 200 is not a perfect square because it does not have a perfect square root based on prime factorization. Okay? So the expectation on your test is you should be able to take any number, do the prime factorization. If you can divide them equally into two groups, then the number is a perfect square. If you can't divide them equally into two groups, in this case 2, 2, if you can't do that, it's not a perfect square. The second thing you should be able to do is say approximate the value of non-perfect squares using a number line. So we just talked about 200 is not a perfect square, right? We know it's not. So therefore, the square root of 200 will not be a whole number. If I went to the calculator and said, what is the square root of 200? It would tell me 14 point big long number, okay? But what your expectation is, you should be able to approximate the square root of 200 using what's called a number line, okay? So the square root of 200, you have to know a few of your perfect squares up to 400. The square root of 196 is 14, and the square root of 225 is 15. So right off the bat, because I've made this number line, the square root of 200 is going to fit somewhere along this continuum, somewhere between 14 and 15. So I know for sure that the square root of 200 is going to be 14 decimal something. I'm just not 100% sure what. Now the square root of 200 is going to be 4 away from the square root of 196, and it's going to be 25 away from here. So it's much closer to the square root of 196 than it is to 225. So on a number line, I'm going to put a dot here and say that's approximately what it is, square root of 200. And if I was guessing as to what it was, I'd say 14.1, maybe 14.2. I can't remember what the calculator said, but square root of 200 was 14.1421, blah, 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 blah. So a good estimation, so therefore I'd say the square root of 200 based on a number line is approximately equal to 14.1. Okay? And the number line is how I could approximate that. That's the second thing you need to be able to do. The third thing you should be able to do is identify all of these vocabulary words. So the first one, the hypotenuse. The hypotenuse is the longest side of a right triangle. It's always across from the 90-degree angle, or another way to say it, it's the third side of a right triangle that does not make up the 90-degree angle. It's the side that does not make up the 90-degree angle. The two sides that make up this 90-degree angle, this side here and this side here that make up the 90-degree angle, those are called legs, and this is called the hypotenuse. Okay? Now in a right triangle, the hypotenuse is always the longest side. The right triangle is simply a triangle that has a 90-degree angle in it. So you can have a right triangle that looks like this. You can have a right triangle that looks like this. All kinds of right triangles. One of the neatest ones is the one that looks like this. Oh, that's not one there. Hang on. Let's do a 90-degree angle there. That's 90 degrees. Okay? But these two are the same length. So that's a right triangle, but it's also, if I drew it sideways here, it's also an isosceles right triangle, where those two sides are equal. Okay? So that's another type of triangle. Another thing you have to be able to identify is a square root. So the square root of a number like 100, the square root of 100, the square root really means identifying what number multiplied by itself gives you the number in question. So the square root of 100 means what number multiplied by itself is 100, and therefore it's 10, because 10 times multiplied by itself is 100, so therefore the square root of 100 is 10. A perfect square is any number that when you square root it gives you a terminating whole number answer. Okay, I guess that's not true either, because it could be the square root of 1.44, and if I take the square root of 1.44 square root, you get 1.2. So I guess we're going to look at perfect squares as being when you square root them, they give you a terminating answer, either a terminating decimal or a whole number answer. Irrational numbers are numbers whose square root, for example, go back to that 200 again. If I take my square root of 200 with my calculator, notice how this number that's right here does not repeat a pattern. And if we were to actually have a larger calculator, if I was to go to a different calculator, let's go to a scientific and put the square root of 200, it actually has an unrepeating, non-terminating decimal answer. And if this calculator was infinitely large, that number would go on forever without repeating a pattern. Those are irrational numbers, numbers that cannot be expressed as a terminating decimal or as a fraction. And finally, the Pythagorean theorem is the area of the squares attached to the legs of a right triangle will always equal the area of the square attached to the hypotenuse. And we call it the Pythagorean theorem, or a squared plus b squared equals c squared. The fourth thing you should be able to do is determine the length of any missing side of a right triangle by using a drawing and a formula. So if I was to give you this triangle, and I was to put this as 5, and this is 6, and this is x, or if I was to give you this triangle, and make this x, and this 5, and this 6, you should be able to solve either with by drawing squares or by using a formula. So the first one, I'm going to actually draw squares on here, or reasonable facsimiles. And since this is a leg and this is a leg, the area of those two squares, which this would be the area of 25, and this would be an area of 36. The sum of those two areas, so 25 plus 36 is 61, would be the area of the square attached to the hypotenuse. Since the area of the square, area of a square equals side squared, and we know that this is 61 equals side squared, then if I just use simple algebra, the side length would be the square root of 61, and that's the exact measurement, or approximately, since 8 is the square root of 64, I'm assuming it's like 7.8 or 9. 61 square root 7.8 is the answer for x, so it's approximately 7.8. Now you also have to be able to use a formula. So if I look at that same question using a squared plus b squared equals c squared, This is your A, this is your B. It doesn't really matter. It could be reversed. It doesn't matter. So 5 squared plus 6 squared will equal the missing side length, which in case now it won't keep C, I'll actually use a variable x, or 25 plus 36 equals x squared, or 61 equals x squared. The square root of both sides would give you approximately 7.8 equals x. That's using a formula to solve it, which tends to be the least popular of the two methods, but it still gives you the same answer. In the second example, I've reversed my 6 and 5, so because this is a leg and this is a leg, I don't know this area, but I know this to be 25 and I know this to be 36. This area plus this area had to give me this, which means this one had to be 11. I can actually use subtraction because 11 plus 25 is 36, or 36 take away 25 must have been the missing side length, so 11. And therefore the missing side length is the square root of 11, which is approximately 3 point something or other. And the square root of 11, where's my calculator? 11 square root should be 3 decimal something. 3 decimal 3. So therefore x is approximately 3 decimal 3 units long. And the final thing you should be able to do is use Pythagorean theorem to solve contextual questions, aka story problems. The one we did today was on the ladder. So let's pretend we have a 2-meter ladder. Okay? Now on that 2-meter ladder, it says the minimum distance from the wall that ladder has to be is 50 centimeters. No, we won't even make it that. We'll make it less than that. We'll make it 40 centimeters away. It's possible for that ladder to be 40 centimeters away from the wall without it toppling over or being unstable. And the maximum distance that ladder could be, we're going to make it 120 centimeters, okay, from the wall, or 1.2 meters from the wall without it falling over. So in situation number 1, there's our wall right there, okay? And the minimum distance from the wall that ladder can be is 40 centimeters. And the ladder, when it's leaned up against the wall, the ladder hasn't changed its distance. So we're going to call this ladder 2 meters, which is the same thing as 200 centimeters. So the ladder is going to be 200 centimeters, and it's going to be a 90-degree angle. So in essence, we have the hypotenuse of a right triangle, one of the legs, and the distance up the wall, where that's going to go up to, is going to be an unknown variable. In our second situation, there's our wall again. The distance from the wall increases to 120, but my ladder's distance doesn't. It's still 200 centimeters. And the distance up the wall is going to be different. It's going to be x this time. So in both situations, we are missing the leg of a right triangle, and we know the hypotenuse in one of the legs. So I'll solve them using drawings, and I'll solve them using squares. So if I draw squares on each of those, 200 squared would be 4 plus 4 zeros, which is 40,000. 40 squared would be 16 plus 2 zeros. And since this is this plus this has to equal this, I can use subtraction to figure that out. It's going to be 38,400. Okay? So therefore, the distance up the wall that ladder would go if it's 40 centimeters from wall would be the square root. The square root of 38,400, which is 195.95, which would round up to 196.0 actually. 196.0. 196.0 centimeters, or 1.96 meters. So the maximum distance up the wall it can go is 196 centimeters up the wall. Okay. The other one's going to be the minimum distance, right? Because it's going to be shorter up because it's farther out from the wall. But the same type of thing is going to happen here. So if I use my theorem, a squared plus b squared equals c squared, this is my a. I don't know it, so it's x squared. This is my b, which is 120 squared. And this is my c, which is 200 squared. So x squared plus 144 plus 2 zeros equals 4 plus 4 zeros. Subtract 14,400 from both sides. I'd get x squared equals 25,600, I think. 25,600. The square root of 25,600 is 160. So therefore, the minimum distance up the wall is 160 centimeters, or 1.6 meters. Okay? So hopefully that helps you with all the different types of things you should be able to do. As long as you can do question 4, like when you miss a leg or you miss a hypotenuse, get the missing part based on the theorem or drawing, you should do all right. If you have any questions, leave comments below and I'll try and answer them as best I can.